Whew, okay, so we're at the next one. We got a test here. So simplify the following rational expressions by rewriting it as a single polynomial denominator. Add, divide. We're just saying you got fractions that you need to either add, subtract, multiply, divide. You need to find a common denominator to do it. Well, in this case, see, if I factor this denominator, because what is that, Malcolm? It's the difference of squares. So that is that. Well, this denominator already has one of those there. It has this one. So all I need to do is multiply this fraction over here by this top and bottom. And because this one has that one in it, I don't have to change this one at all. So I'm going to take this first fraction to get my common denominator and multiply it times x plus 2, and then multiply the bottom, x minus 2 times x plus 2. And then I'm just going to add the what I already got. Right? So now that I got that, I'll multiply this, and I'm going to get x squared, because I use FOIL, or on box method, however you want to think about it, x squared plus 3x plus 2, and then that's plus x minus 1 all over x squared minus 4. So I add the x to there, and I subtract the 1, so I'm going to get x squared plus 4x minus 1 divided by x squared minus 4. I can't simplify that at all. This is my answer. Now, as I told you the other time we were doing a problem like this, you kind of want to think about the domain. Um, what x's can't you use? What x's can't you use? You want to think about that. So in this case, but what I told you was don't worry about the domain unless I mention it in the problem. I'm still going to do this just because. Because the bottom factors to x squared or x minus 2 times x plus 2, my x cannot be 2 or negative 2. So that goes for both of these because they're both the same denominators. All right, so now I got this one. So this is a division problem. So what kind of the problem is that, Kamaya? Yep, it's keep, change, flip. So I keep the first one. I change that to a multiplication, and then I flip. So this right here factors to this x plus 2 times x minus 2. And then, because I'm multiplying, I can cross cancel. I can cancel that off and that off. So then what am I going to have left? I'm going to have x plus 1 times x plus 2. It just goes away. And then I'm going to have on the bottom just x minus 1. Now, nothing here can be simplified either. So that's my answer. All right. And then when I was saying x can't be this or this one, because the bottom changes, x can't equal, x can't be negative 1. So that's something else I got to put in there. But like I said, I don't want to confuse you. So don't worry about the domain unless it says in the problem domain. So what is the domain? There we go. This is one you got to worry about. Express the rational expression in lowest terms. So we're going to reduce or cross cancel or simplify once we find out what our domain is. So our domain is 2x plus 8 equals 0. Remember, I'm trying to figure out what values of x will make that 0. So I can factor out a 2. So now I got x plus 4. Makes you feel better to put that 2 on the outside. You can. So 2 doesn't matter, but x plus 4, how do I get 0? X plus 4 equals 0. Subtract 4 from both sides. X equals negative 4. So my domain, x cannot equal negative 4. So now I simplify. So I've got x squared minus x minus 12. So I think of what two numbers do I multiply Or what two terms do I multiply to get x squared? Well, that's easy, x and x. What two things do I multiply to get 12, but when I subtract them, I get 1? I know that I'm subtracting because this sign is a negative sign. So what two numbers do I multiply to get 12, but when I subtract, I get 1? That's right, 3 and 4. So now this sign right here tells me which sign, what the sign of the highest number, because that's minus, this is minus, that's plus. I know it's minus and plus because this sign is negative. Negative 4 times a positive 3 is a negative 12. Okay? Then I factor the bottom. I pull out a 2, and I've got x plus 4. Well, here, right here, I can't simplify it. None of these things are the same, so that's my answer. That's 3 times I gave you problems that they couldn't simplify. I'm probably not going to do that again, just a heads up. Okay. So the next one, what is the end behavior? Well, I think about this problem. I've got x squared minus 1 and x plus 1. If I look at it separately, the denominator and the numerator, that negative 1 is kind of inconsequential. The big deal is the x squared. And then here, x plus 1. Well, if my x is 1, I mean, it doesn't really matter. But, excuse me, what I do need to notice is that that if my x gets bigger, that 1 is inconsequential. Because if it's like x is a million, what does it matter that I'm adding 1? So it's a million and 1. Whoop-de-doo. All right, so then that's going to be x. And I'm going to put a couple dots. So then that means that it's going to be like x squared over x. Well, that simplifies to just x, right? So with that, now I think about if x is going to infinity, that means f of x is going to infinity. And then here, if x is going to negative infinity, f of x is going to negative infinity. And that's the end behavior. For this one, when I've got just a polynomial, so I got a bunch of expressions, I look at the term with the highest degree. That's x to the second power. And what ends up happening as my x's get bigger, the x squared is going to take over this. The x and the 1 are going to be inconsequential. So I think about this as x squared. So if I think about this as x squared, when x goes to infinity, as in when x gets bigger, when it goes to positive infinity, as x goes to 1,000, and then 10,000, and then 100,000, and then a million, and then a trillion, what happens to f of x? It goes right along with it. So as x goes to positive infinity, f of x goes to positive infinity. As x goes to negative infinity. So as x is getting a smaller as negative numbers, so negative 1, negative 10, negative 1,000, negative 10,000, negative a million, as that's happening, what happens to f of x? Because the main thing is x squared, it's just like I was telling you the other time. If I put a negative number in for x and x is x squared, then the negative cancels off. So that's going to go to positive infinity. So here's one of those times. You want to watch what this does, okay? I'll give you another problem that's similar that you can see what happens, okay? Okay, so for the following pairs, find the domain and indicate if the functions are the same. All right, so first off, if the functions are the same, I'm looking to see if they have the same domain and if they kind of reduce to become each other. Okay, so if I look at this, what is the domain for this? Well, the domain is x cannot equal negative 1, because if I get negative 1 and plug it in here, I get 0 in the denominator. Well, this one, if I factor this, x and x, what two numbers do I multiply to give me 2? When I add them, I get 3, 1 and 2. So when I factor this, this is telling me that x cannot equal negative 1 or negative 2. I can already see that they're not the same because the domains are not the same, right? Because the domains are not the same, they're not the same. So if I factor this, I've got x plus 2 over, and then if I factor this, these two things cancel each other out. So I would have 1 over x plus 1, but these would not be the same function because the domains are not the same. So nope, because the domains are not the same. The f of x domain is x equals, or x cannot equal -1 or -2. The g of x domain is x cannot equal -1. So that's why it's no. So I'll look at this one. What is the domain? Well, remember what the domain is. The domain is restrictions on your inputs. If I look down here, I can't factor this. There's no number that is going to give me a negative in the denominator. If I put a -1 in there, I get +1, -1, -1 plus 1 is 0, but then I've still got +1 here. Because of the way this is set up, I'm not going to get a 0 in my denominator for any number I put in, any real number I put in. So then the domain for h of x, or h of x domain, is all real numbers. If I start putting in i's and radical things and all this and that, maybe I could find a way to get 0 in the denominator, but we're talking about real numbers, so i's don't count. And if I say, what is the k of x domain? Well, there's no restriction, there's no fraction, there's no nothing, so I can put in whatever x's I want. So all real numbers. So that's the first hump, is that the domains are the same. Now I'll look if I can reduce the top function to become the second one. Well, if I look at the top, I can pull out an x squared. See? Every one of these terms has at least an x squared in it. So let's put it down here. So if I pull out an x squared, what am I left with? Well, x to the fourth, if you pull out an x squared, you're left with x squared. X to the third, if I pull out an x squared, I'm left with x. And then x to the second, if I pull out an x squared, I'm just left with 1. And if you look at that, you see that those two things cancel off, and I just got h of x equals x squared. So are those the same function? Yep, because the domains are the same and they reduce to the same function. So now what do I have here? I need to find my vertical asymptotes and my horizontal asymptotes. Now vertical asymptotes are easy. You find what makes the denominator 0. So vertical asymptotes, or asymptotes, what makes the denominator equal to 0? So it's almost like you're trying to find the domain. So x plus 5 equals 0. Subtract 5. So the vertical asymptote is x equals 5. So the horizontal asymptote is a little different. So I need to look at my variables. So the numbers, the constants, they kind of fall off. So the horizontal, I'm going to reverse this and make that -4x plus 6. All I did was switch the order over x plus 5. So I could have this and just focus on the x's. These two things are going to fall off. It's almost like I'm trying to do what I did when we were looking at end behavior. I pay attention to the term with the highest degree, right? So if I look at this, the highest degree is 1 for both of those. Because remember, when a variable has no exponent, the exponent is 1. So I'm going to focus on those parts. I'm going to focus on this, not the 6 and the 5. Okay, so I've got negative 4x over x. Well, the x's are going to cancel off, and my asymptote is negative 4. That's what my horizontal asymptote line is. Now remember what that means. It means I've got my graph that's a coordinate plane, and then these asymptote lines are imaginary negative lines that are restrictions from my graph that my graph can't cross. So there's a line that goes down x equals negative 5, and then there's a horizontal line that goes, this is y by the way, sorry. Y equals negative 4, so that'll be like, it's y equals negative 4. So there are these two imaginary lines, so my graph can be all around these, but it can't cross those lines. Okay, so now I'm going to do the same with this one. So vertical first. So I got the vertical. That is x squared minus 9 equals 0. Well, this can factor because that's the what? Charlotte, what is it? It's the difference of squares. Say it.
It's the difference of squares.
Thank you. Why don't you want to say it? You want to say it too? Okay. So that's the difference of squares. X plus 3 times x minus 3 equals 0. Thank you, Charlotte. And so then that means if I'm looking at what values make this 0, x can my lines, excuse me, not that. So my lines are going to be x equals 3 and x equals negative 3. So now what about my horizontal? Well, horizontal asymptotes. Well, I look at the highest degree, my variable. If there's no variable up there, I think about it as x to the 0, right? So I got x to the 0, and I got x squared down there. So what am I going to have? It's going to be 4x to the 0 over x squared. The other stuff falls off, right? Well, x to the 0 is 1. That's not going to be anything. So that's going to be 0. Because I'm looking at my exponents, x to the 1 isn't really there. So because I have no exponents, other than 0, that I can't really cancel that off. So this is going to be 0 over x squared. So my horizontal asymptote is 0, or y equals 0, excuse me. So what does that mean? That means I've got my graph, and then I've got two lines. I've got an invisible line that goes off of x equals negative 3 and and x equals positive 3. And then I also have an imaginary line that's over y equals 0, so that's right here. So my graph would be either somewhere here, somewhere here, somewhere there, somewhere here, somewhere there, somewhere there, but it wouldn't cross those invisible those dotted dash lines. They're like guider lines. All right. So next, this goes back to the composition of functions. So composition of functions, f of g of x. So I'm going to take the g of x equals x plus 4, and then I'm going to take that and put it into f. So f of x plus 4 equals, well, that's 2x, so that's 2 times x plus 4. That's simple. So f of g of x equals 2 times x plus 4. Now I've got it set for a number. So g of 3, well, g of x is x plus 4. So g of 3 is 3 plus 4. So 3 plus 4 is 7. So now that I got 7, I'm going to plug it in. So f of x equals 2x. So f of 7 equals 2 times 7, or 14. That's my answer. So f of g of 3 is 14. So here again, I got composition of functions. So g of f. So that's g, that's f. So I'm going to take f of x equals 3x plus 5, and I'm going to plug it into g. So g of 3x plus 5 equals 3x plus 5 to the second power plus 7. See what happened? I took this function and put it in here. Took this and plugged it in here. So now I got to do FOIL. So that's 3x plus 5 times 3x plus 5 plus 7. So that's 3x times 3x, that's 9x squared. 3x times 5, that is 15x. 5 times 3x is 15x. And then 5 times 5 is 25 plus 7. So now I have my like terms. So I got 9x squared. I've got 30x plus 32. And that's my answer. So that's what g of f of x is. So this one, I got -3. So I'm going to plug -3 into f. So f of x equals 3x plus 5. F of -3 equals 3 times the -3 plus 5. So that's -9 plus 5, that is -4. So I'm going to take that -4 and plug it into g. So g of -4 equals -4 squared plus 7. -4 to the second power is positive 16. Positive 16 plus 7 is 23. So now, next I want to get the inverse of functions. So the inverse, I'm going to rewrite this as y equals 4 over 5x plus 3 over 2. I want to switch the y and the x. I want this to be x equals something. So the way I'm going to work it is I'm going to leave the y the way it is, and then we're going to go back to our function notation, f of x, after we're all done. So what am I going to do? I'm going to start by getting the x by itself by subtracting 32 from both sides. Okay? I want to get x by itself. So the next thing I'm going to do is multiply both sides by the reciprocal, 5 over 4. So if I multiply 4 over 5 times 5 over 4, I get 1, so they cancel each other off. So I have x. So what equals x? 5 over 4 times y is 5 over 4y. Minus, so now I've got 5 over 4 times 32. Put this in gray over here. 5 over 4 times 32. Well, if I stick a 1 under that, I can cross cancel. 4 divided by 4 is 1. 32 divided by 4 is 8. So now I've got 5 times 8. So that's 40. So that's going to be 4 over y, 5 over 4y minus 40 equals x. So now that I got it like this, I'm going to change it back to function notation. So I'm going to change this to f of x and that to x. So this is the inverse of x, which equals 5 over 4x minus 40. And that's my answer. That is the inverse of that. So now I'm going to get the inverse of this. So I'm going to change that to y. I want to get x by itself. So the first thing I'm going to do is minus 3 from both sides. So that's y minus 3 equals x squared. So how do I get rid of an x squared? I need to think about that. Because this x squared, I do the opposite of squaring, which is square rooting. So the square root of y minus 3 equals the square root of x squared. That's going to cancel each other off. So I've got x. The square root of y minus 3, right? And so now I'm just going to, now that I got to this point to where x is by itself, I'm going to change the notation again. That's f of the inverse of x equals the square root of x minus 3. And that's my answer. All right, last page. So I've got determine whether the following pairs of functions are inverses. So here I'm going to do, I'm going to look and see what the inverse is, and then if they equal each other. So let's pick one, and then we're going to try to turn it to the inverse to see if they're the same. So let's start with g of x. So I'm going to say g of x equals x plus 1 squared. Well, I want to get to x. So first we're going to make that y. So y equals x plus 1 squared. I want to get rid of the squared, so I'm going to take the square root of both sides. The square and the square root cancel each other off, so now I got the square root of y equals um, x plus 1. So then I'm going to add 1 to the other side. So, I'm sorry, subtract 1 from both sides. I'm going to have the square root of y minus 1 equals x. If I change that to the inverse notation, the inverse of x equals the square root of x minus 1. Is that what I got right there? Yes, it is. Now, just to be on the safe side, I can use this little space here and see if I take h of x and see if I get the same thing. Well, I've got y equals the square root of x minus 1. So I'm going to add 1 to both sides. So now I got y plus 1 equals the square root of x. I want x. So how do I get rid of the square root? By squaring both sides. So I'm going to square both sides. So when I square both sides, the square cancels off the square root, and I'm just going to have x equals y plus 1 to the second power, and then I change back to function notation. F of the inverse of x equals x plus 1 squared, which, yep, so these are inverses. If I take the inverse, I get the other one. So now I got to do the same here. So I'm going to start with the easier function. I'm going to start with f of x. So I got f of x equals 6x minus 5. I'm going to change this to y. So let's change that. Okay, so I changed that. So I want to get to the x. So I'm going to start by adding 5 to both sides. So now I got y plus 5 equals 6x. Well, I'm going to divide both sides by 6 because I want to get to the x. So that's going to give me the x. Here, if I divide both sides or both sides by 6, and I get this divided by 6, I'm going to just split the fraction up and say this is y over 6 plus 5 over 6. And then if I change it to function notation, f of inverse of x, or I'm sorry, I've been saying it wrong. This is the inverse function of f. Anyway, that's going to be x over 6 plus 5 over 6. That ain't the same. This right here is different from that. So if I want to get all fancy, I could say f of negative, well, the inverse of the function f of x is 1 over 6 times x plus 5 over 6. 1 over 6x is not the same as negative 5 over 6. So the answer right here is nope. I can stop right there. I don't need to check the other one. If they both don't equal, then it doesn't matter. So all I need to do is do one and get a no for it to be no. Okay. The last problem on here is the inverse function dealing with logarithms. This one's a little tougher, so I'm gonna work with this one first. It's all about remembering the log rules. There are a bunch of log rules, okay? Like for instance, if I take the log, all right, if I take the log of this problem right here, what is gonna happen is it's gonna take me straight to the exponent. Okay, if I take, so first I'm gonna write y equals 4 to the x plus 2 power. So next, I'm going to take the log of both sides. So log of y equals the log of 4 to the x plus 2. So what happens is when you take a log of something, these two things cancel off, and you're left with just the exponent. So I'm going to have log of y equals x plus 2. And then I'm going to subtract 2 from both sides. And so I'm going to have the log of y minus 2 equals x. Then I'm going to change this to inverse notation, inverse function notation. So the inverse function of x equals log of x minus 2. And that's my answer. Now this one's trickier. Okay. So first I'm going to give myself y equals 3 times the log of 7 of x plus 5. Okay. So first off, I'm going to divide both sides by 3 because I want to get rid of that 3. So those 3's cancel off. So now I'm going to have y over 3 equals the log of 7 base times, or sorry, the log base 7 of x plus 5. So if I take both sides to the 7th power, or I'm sorry, I said that wrong. If I take this exponent and raise it as a power of 7, and then take this log and raise it to a power of 7, I'm probably saying it wrong. But bottom line is you can see what I'm doing. I'm making whatever's there the exponent of 7. So what happens here is when I have a log of the same base that I'm taking as a base here, those whole things they cancel each other out. So now I'm going to have 7 to the y over 3 power equals x plus 5. And then finally I'm going to subtract 5 from both sides. And I'm going to say 7 to the y minus 3, or excuse me, 7 to the y divided by 3 power minus 5 equals x. And then finally, I'm going to take this to the negative, well, the f function inverse of x equals 7y over 3 minus 5. Not x. Oh, man, yeah, I've probably been doing this too long. So the inverse function of x equals 7 to the x divided by 3 power minus 5. That's my inverse. So that's all of them. We're going to look probably Monday about um, about these rules, and we'll look at each thing individually and go back to what sections they covered and whatnot. All right. So look at those, and what I might do is maybe I'll drop another video with each section. All right.